Hi student, welcome to probes in CMM class. So in this class we discuss about probe systems. So we have seen what is CMM in previous class. So in this class we are going to discuss about probes. So we have used probes in coordinate measuring machines. So probes is a very essential component in CMM, which is a arm of the touching sense based arm of the that machine. So we are human, we have a hand, in that hand we have touching fields, and by the hand sensing and skin sensing we giving feedback with the help of mind. So like that in CMM we using software and physical component as well as touching sense component called as a probes. These probes have many types. So let me see what is probe in this class. So this is a typical probe. So this is a physical structure of a typical probe. So in this probe we can find C spanner location. So this is used to detach and attach purpose of probe in the probe arm, which is available in the coordinate measuring systems. So this is a probe body, and this one is a alignment marks. So this alignment marks is used for reference purpose, whether it is probes in initial stage or it is rotated to another angle variations like that. So whenever you going to start a new component, we can check whether it is probes settled in the initial stage. So this is a this mark, alignment mark, used for to refer whether it is in initial stage or it was in turned over like that. Okay, next is probe module. So this probe module having some programmed systems. Okay, and this is a magnetically held kinematic coupling. So this is a magnetic application based on kinematic coupling. Kinematics for moving purpose, displacement purpose. Okay, then module change rack location groove. So this groove is used for module change purpose, is a mechanical rack. Then front ring is also there. Then color coded protection cover. So this is a color code protecting cover is available. Standard force black, medium force gray, extended force brown. So lot of colors available: black, gray, brown, and black for standard force, gray for medium force, and brown for extended force. So why we using force here means based on the component measuring, based on the component, based on the measuring situations, we need to use the pressures, forces. So for that we having color system to identify the what type of force we using to measuring during inspection with the help of probes in CMM, that is coordinate measuring machines. This is a balls. This is called a stylus. End of the stylus we can find a ball. So this is made up of some ruby, diamond, etc. So this ball is going to touch, going to inspect the components. So first one, so types of probes. First one is touch trigger and analog scanning. So in contact type and non-contact type are there. So there is a contact and non-contact. So probes can touch, otherwise probes cannot touch. So two basic systems are there. One is contact and another is non-contact. In non-contact, so there is no any touching with the component is not happens, but in contact there is a touch trigger available, analog scanning available. For inspection of printing circuit board, measuring a clay of wax model, when the object being measured would be deformed by the stylus. So whenever we using CMM, there is a probe available. In that probe, touching probe is there. So these touching probes are used for rigid type of components. For example, it is made up of metal means we can use the touching type of probe system. If it is a material which is deformed due to the pressure of force of probe means we cannot adapt these type of. So let me move for non-contact type of system. Stylus we need, non-contact stylus we need it. So in that manner we can see laser probes and video probes. So these tools are used for non-contact types. In touch trigger probe, yes, the sensor makes contact with the part. The difference in contact distance indicates that the probe has been deflected. The computer records this contact point coordinate space. An LED light and an audible signal usually indicate contact. Touch probe assemblies consist of three components: probe, one is probe, second one is head. Okay, probe are there, probe heads are there, and stylus. Okay, three components are available. In analog scanning probe used to measure contour surfaces, complex irregular, and also used for improve the speed and accuracy. So in non-contact analog scanning probe is used for, sorry, contactable analog scanning is used for improving the speed and accuracy. Remains in contact with the surface of the pot as it moves. Next one is non-contact type, that is laser scanning probe. Laser probes project a light beam onto the surface of the part. When the light beam is triggered, the position of beam is read by triangulation through a lens in the probe receptor. Laser tools have a high degree of speed and accuracy. Of course, contact type of probe system have a high speed and accuracy, but compared to laser non-contact type, it is far ahead compared to contact type. Okay, so non-contact type is far ahead of contact type. Then video probe, the feature or measured by computer count of the pixels of agnomatic electronic image, so based on image processing and pixels. The camera is capable of generating multitude of measurements points within a single video frame. So laser scanning we use in laser lights, lenses, etc. In video type we using cameras, and image processing we are adapting for the inspection system. So this is a trigger type probe system. So this is a part section of probe head trigger types. So trigger type nothing but there is a touching type of stylus available. This is stylus and this is ball. So this ball is touching the component and travel along the surface of the component and measures the dimensions. This is a inspection. So by this way the touching trigger type of probe system does its job. So when it touches there is a microswitch available. So these circuits helps to get the electrical signal, and this electrical signal is sent to the amplifier and finally sent to the monitor. Okay, so this is a outline of probe kits. This is outlines, so it can move any type of direction. So next one is measuring type of probe system. This is a one type of probe. This is a typical image of another type of probe. So it have a Fi, Fz, Fx, three directions are there. So movement of these directions happens through this connector. Okay, so this is a component. It's a graphical representation of movements. It can rotate. Okay, so this is a rotational reference system. This is a type of modern probe systems. So this is one type of probes. So this is a stylus, this is probe, this is stylus, and this is a ball tip. Here also ball tip available. This is a ball tip available. If you see, stylus is different, ball tip is different. So this type of probe having multiple ball tip, 1, 2, 3, 4 are available. Okay, so these fours are doing work at each depth based on depths. Okay, and this is also one type of probe systems. This is one type of probe systems. Stylus are different, systems are different based on the manufacturer styles looks are different, but the system of the measuring system is a same. And this is a probe system in general image. This is a application oriented machine. In manufacturing they will have some aesthetic look and LED systems, green light, red light for reference purposes. Measuring type of probe system. So we can see the stylus only. So here we have seen in previous slide with the probe and attached device. So here only we see stylus. So this is a length rod, and at the end of the length rod the ball tip is available. This ball is made up of ruby, diamond, non corrosive materials. The ball should be non corrosive type, and the electrical conductivity must be there, and third one is it should be non-wearable. It should not wear and tear. Okay, but if it is any wear and tear happens, the measurement systems may get error. So these are one type of systems, and lot type. These are multiple manufacturing based stylus and probes. This is a graphical view. So its axis is this laser type. So this laser beam splits and sends the component to measure and reflect to the linear reflector. So linear reflector available, working table of CMM available, laser beam filter available, laser head available. So whenever it passes, it senses the measurable devices and doing its work properly with the help of laser splitters. So this lasers doing its work with high speed and with high accuracy. So it can move as well as for x-axis and y-axis, z-axis. 3 axis is feasible in the non-contact type of probe, that is laser probe systems. The components will be remain same, some aesthetic will be same, and some features will be added. This is a zoom image of that ball type. So it will look like, so this is a application animation image. This is not animation, but we can see the image, we can understand how the probe moves around the component. So it will move around here and there and rotate over the component and senses this inner and outer and the cylindricity, etc., based on the movement of the probe. So likewise it moves and touches and non-touches. This is a touching type trigger, it touches. Okay, non-contact means this will be a laser type. Let me say applications. Coordinate measuring machines find applications in automobile, machine tools, electronic space, and many other large companies. So it's used for automobile, mostly used for automobile components, and the machine tools, electronics components, space, etc. These machines are best suited for the test and inspection of test equipment, gauges, and tools. For aircraft and space vehicles, 100% inspection is carried by using CMM only, because aircraft systems are we need to manufacturing in very accurate level manner, otherwise it may lead to accident. So the 0 error should be maintained. So for that purpose CMM is used to inspect 100% aircrafts and space vehicle components. These are ideal for determination of shape and size, position, maximum metal condition, sorting task. So it is also used for not only inspection, that is measuring type of dimensional measuring inspection system, it is also used for shaping, positioning, maximum measurable condition, and sorting the task. Sorting, for the sorting also we can use the CMM. So next is, it is also best for ensuring economic viability of NC machines, that is numeric control machines, by reducing their downtime for inspection results. They are also help in reducing cost, rework cost at appropriate time with the suitable time, because it doesn't need any rework, because when it is using, when you start to inspect, it will not do any mistakes unless otherwise any external medium affect on disturb on that machine. If it is in a good condition, there is no any external disturbances happens, it will do its job 100% perfectly. So it avoids rework, hence we can know, we can use optimize time, we can utilize actual needed time, we no need extra time. So this extra time what happens, consumes electricity and operations having more alignment purpose, and we should take care by the human also we are involved here while cmm, because ideal time is coming. If ideal time is there means human also available, they also help in reducing cost, that is what. So the time optimization helps reducing the cost. cmm can be used for determining dimensional accuracy, yes of course. Advantages: the inspection rate is increased, so we can inspect more component compared to manual. Whenever we using inspection through manual, the component will be limited only, but when we using cmm, the limitation is not that much, we can use more component, limitations is going to be negligible. Then accuracy is very well, and operator's errors can be minimized. Skill requirements of the operator is reduced inspection, fixed turning and maintenance cost. So there is no any maintenance cost. Of course, a maintenance cost so will be a negligible. Okay. Reduction in calculating and recording time. So there is no need of calculating and recording time. It will calculate, it will record. Okay. No need of separate go or no go cages for each features. Reduction of scraps and good part rejections. Reduction of scraps. So we can save our raw material. So when after completing the product, we came to know this product having some defects. This creates scraps. So scrap increases, the process will be twice. So this increase the cost of the processing, and also this cost divided into the each every component, hence the product cost rises. It can be avoided when we be using cmm by means of reducing scrap and good part rejections. Disadvantages: yes, we have a lot of advantages in cmm, even though we have some disadvantages on cmm. The table and probe may not be in perfect alignment, so table and probe should be in proper alignment, that is very very important. That is what they given the alignment mark at the probe. The probe may have run out, it may dismantle itself. Okay, it is detachable and attachable, no, for that. The probe moving in z axis may have some perpendicular errors. Probe while moving in x and y direction may not be square to each other. That means equal distance travel will not be happens in x and y direction, that is what they are saying. And in z directions, vertical movement, during vertical movement maybe some errors happens due to sliding components creates errors. There are maybe errors in digital systems, of course. Software failure and signal processing units get damaged due to heating, so this causes errors in digital systems. It can be replaced by quality manufactured systems. Okay, if it is we using any poor quality type of control circuits, it may lead, when we manufacture in good manner, it will have a good life and reliability. Causes of errors: so the table and probes are in perfect alignment. The probes may have a degree of run out and move up and down in x z axis may occur perpendicularity errors. So cm should be calibrated with the master plates before using the machine. So we calibrating vernier caliper, we calibrating micro gauge, height gauge, bevel protectors, even sign bar, even slip gauges. So also cm also going to calibrate, even it is a computer based machine, automated machine also, but we needed to calibrate. Dimension errors of cm is influenced by the straightness and the perpendicularity of the given guide weight. The guide weight should be a proper straightness and flatness. Scale division and adjustment probe length, probe system calibration, repeatability, 0 point setting and reversal error due to digitization environment. These are causes happens in causes of errors in CMM. And other errors can be countered by the manufacturer and minimized by the measuring software. The weight of the workpiece may change the geometry of the guide base, and therefore the workpiece must not exceed maximum weight. So each and every component, the CMO machine should be changed. We cannot use small type of CMM for measuring large type of component. Variations in temperature of CMM specimen measuring lab influence the uncertainty of measurements. So heat influences the errors. Translations errors occurs from error in the scale divisions and error in straightness perpendicular to the corresponding axis direction. Of course, perpendicularity errors occurs in three axes are not orthogonal. So thank you guys.